is this guy right here. So we're taking a big triangle, and when we draw that altitude in, it creates two more triangles, this one here and this one here. So we now are actually looking at three different triangles, the original big one, and then the two smaller ones that's created by that altitude. Okay. When we do that, we create now three different triangles that are all similar to each other. So what we did yesterday for a couple of them, just to sort of set up a problem, these are the longer ways to do them, but I do want you to do it one more time, is sketch all three of these in a way that we can see how they are similar. So the one that we're going to start with for triangle number one is the one that I think is the easiest to kind of sketch, and that's going to be the blue one. So for triangle number one, we are going to draw that over here all by itself. So this triangle, just draw it the exact way it looks on the paper. The 90-degree angle is right here. And then I want you to label these with the variables. So for just doing the blue triangle has a vertex here of T, and it goes to the right angle of R, and then it goes up to P. So that's our blue triangle. We want all three of them to look like that. So we're gonna do some rotating first with the yellow triangle now. So now if I go to the yellow triangle, so last year we talked about how you would have done some rotating and reflecting. We want to rotate that rectangle 90 degrees counterclockwise so that it still looks like this first one. It's going to be the smallest of the triangles. So let's draw that a little bit smaller. If we look at this yellow triangle, isn't the right angle in the yellow triangle also R? So this right angle right here is still going to be R. All right, that's this guy. And then we have two legs. We have the smaller leg goes from R to A. So when we look at the smaller legs over here, or the two legs, here's our smaller one. So this has to be RA. And then the longer leg is this altitude from R to P. All right, this guy. So the longer leg over here would have to be R to P. And then the one that's probably the trickiest to draw in is the big triangle. So draw this so that it's the biggest, but draw it in a way that, again, our right angle is the bottom right-hand corner. In the big triangle, the one I have highlighted in red, our right angle is up here. This is the angle that has that 90-degree little square drawn in. That is angle P. So this now right angle in the big triangle is angle P. The short leg of the big triangle goes from P to A. All right, so if you can see my little cursor going back and forth, the short leg is P to A. So that means if this is our short leg, this is P, this is A. And then the long leg goes from P to T. Those are all similar triangles. What I want you to do also in this one is we're going to write a similarity statement for these. So we'll do triangle. We'll do triangle number one, and I'm going to do it in this order. I'm going to go T, R, P. So angle T, angle R, angle P. That triangle is similar. And then if I go to angle number two, since I went in this direction, T to R to P, angle two or triangle two should be P, R, A. And then both of those are similar to the third triangle. We'd have to write that as T, P, A. All right. So like all those proportions we were doing before break, if we wanted to, if I started assigning values to all of these, so don't write this down, just making these numbers up in my head, we could now start putting these in those correct locations, start setting up proportions for all of them. But to draw out the three triangles every single time and then try to do our algebra problems from there can be tedious and long. So we had these shortcuts. All right, that's what these 6 problems should bring back. And then hopefully by, again, the end, we have these down. So if we go to number 2, we could, if we want, we have the big triangle here. We could draw that out. And then we could draw in this triangle. And then finally the third triangle that's created in here. And then look and see what sides correspond to each other. But that is a process. Okay. What we instead did is we talked about some shortcuts. And the shortcuts were based off of the very first couple of problems we did yesterday. And that is how we found a geometric mean. And the way we found a geometric mean was with this proportion. All right, so we wanted the number. I think I gave you like 4 and 18 yesterday. Don't write this down. You'll confuse yourself, so you can look at it later. But we wanted the number between 4 and 18 that is the geometric mean of 4 and 18. And the way we calculated it was with this formula here. Okay. So when we have a triangle, so here is our big triangle. And it is then drawn an altitude to the hypotenuse. So we draw an altitude to the hypotenuse of that. That's when all those little shortcuts would apply. Okay. So what we talked about yesterday, the first shortcut is the mean is whatever this altitude is. So one of the means in our shortcuts is going to be the altitude that we drew in at the beginning. So for this particular problem, we are going to slot the 6 into this position and that position. So we're going to do 6 here and then 6 there. So the geometric mean will be that altitude. Notice when we did draw that altitude in then, notice how it intercepts the hypotenuse right here and it creates 2 segments. Those are what 6 is the geometric mean in between. So one of them goes here, one of them goes there. That's the hard part. Okay, that's the new part. From here, it's just now us solving a proportion where we're going to crisscross and multiply. So the 4x, the 6 and the 6 multiplied together would give you 36. If we divide by 6, then we find that that x length was 9. All right. So that was our first shortcut number 1. And you'll have the same thing in number 2, where here is the big triangle. And this altitude is drawn in. And the altitude is your geometric mean. So if we set this up in its generic form without any numbers, this altitude that I'm highlighting in red, that is your geometric mean. So that is why we're going to put the x's into those 2 spots. And then like we said in that previous one, when it does intercept the hypotenuse right here, notice how it creates 2 lengths. It creates this length here and it creates this length right here. Those are the numbers that we're looking for the geometric mean in between. All right. Now, when we cross multiply here, we revisited these yesterday for the first time in a while. Because the 20 and the 25 is pretty nice. That'll give you a 500. But we had to revisit the idea that an x times an x was an x squared. And what we revisited was, how did we get rid of squares? What operation gets rid of a square? Yeah, square roots. So you're going to have to take the square root of both sides. We would have said initially this was positive or negative, but since it has to fall in between 20 and 25, we can't have the negative. And then we had to remember how we would break these up. So we wanted perfect square that would be a factor of 500. There's a few of them. Anybody feeling smart today? What's the largest perfect square that would go into 500? What is it? 22? Is not 500. But we're trying to find numbers that multiply to be 500 first. You got a Sitch? Good. So the nicest one would be 105. 25 also works. Mirna. Was that you, Mirna? It was Diana? Get out of here. Really? Wow. No wonder it seemed weird to me. That is correct, Diana. Except we can go bigger than 25, and we always want to use the biggest one. And the 100 would be the biggest. Because what is the square root of 100 then? I wasn't necessarily asking you in particular, so you're not good, but she knows that. So that's 10. And then the root 5 we can't do anything with. So we would write that answer as 10 root 5. All right, so that is shortcut number 1. When we have our right triangle and this altitude is drawn in, that altitude is the geometric mean of these two segments here. Or if we separated them and found our similar sides, that's the proportion that we would set up. Again, yesterday we were doing both of them. Now we're just going to use the shortcuts. All right, when we go to this number 4 now, let's write out that general formula again. So the extreme over the mean equals the mean over that extreme. Here is the big overall right triangle. Here is the altitude that's drawn to the hypotenuse. Notice now how, are there any markings given to the altitude right here? No. So this is how we would now recognize this is the other shortcut. This is the other type of a problem. In the first couple, we were looking for this, or you were given this at 6. You were looking for this x value as your altitude. Now, I'm not concerned about this. I'm not asking you to find that. We could if we wanted, but it's not the question. What we are now looking for is this right here. So again, a little review of yesterday, some old stuff. In a right triangle is comprised of the hypotenuse. That's the opposite side of the right angle. And then it's comprised of 2 legs, which are the other 2 sides. The second shortcut is this mean is the leg of the triangle. So it could be this guy, but again, I'm not asking you about this one, so we're not worried about that. The one I am asking you about is over here. So now the leg is your mean. So I'm going to put an X here, and I'm going to put an X there, since that's the length of this leg. And that is the geometric mean of, if we read through yesterday's, if I pulled up yesterday's notes, the notes would have said the adjacent segment on that hypotenuse. So since this is our leg, adjacent means right next to. So the segment that's right next to this on the hypotenuse is right here, and that has a length of 4. So that's one of the numbers we're looking for the mean between. And then it said the overall hypotenuse, which would be this entire length of this entire segment here. That would be what? 36. The 4 and the 32 together give us that full hypotenuse. So we would put a 36 right there. All right. Cross multiply then once we have it set up. This is also, I think this is a nice one. Yeah, this was the 144 when we multiply 4 and 36, and then x times x is x squared. We get rid of the square with the square roots. And the reason this is a nice one is, what is the square root of 144? 12. So then this, we don't have to worry about perfect squares. That's just a good old whole number of 12. All right. Okay, 5. Same rule. If you look at the big triangle, notice how I'm not asking you for the altitude. So that's why we know we're not doing the one that we did at the beginning of class. This is not what we did in 2 and 3. What I am asking you for instead is this leg right here. So that is the other thing that could be your mean. It's either the altitude or the leg. Oops. And in this case, it's the leg that we are looking for. So that is why the mean in this case is the x. So we're going to put x into those 2 slots. Tell me what these 2 are. Write those down real quick. See if you understood how we got those 2. This is the one that people tend to miss. The first little shortcut people tend to get fine. This is the one that people make a little mistake on. So see what you think goes here and here. All right. The rule is the length of this leg is the geometric mean between the adjacent segment along the hypotenuse. So 2 should have been one of them. What should be the other number then here? What do you think, Fabian? Good. That should be 14. That is the length of the overall hypotenuse of the big triangle, which is the sum of the 2 and the 12 together would give us that full length. Okay. That's our setup. Cross multiply. This unfortunately is not a nice perfect square, so we'll have to revisit the simplifying of a radical. When we take our square root, 28 is a nice one. That won't take us too hard to find that one. That's 4 and a 7 will give you 28. 4 is that perfect square. Square root of 4 is a 2. Oops. And then that is equal to x. All right. Okay, try to set up 6. Once you have it set up, don't go any further because the solving of 6 is a little tricky, but the setup should be similar to what we just did a couple of times. There's a couple sneakier parts with this one, but see if you understand the shortcut first and foremost. And then I wouldn't, once you set it up, don't try to solve it because it's a little weird from there. All right, let's see if we got this set up right. These two positions here, the mean, the geometric mean, it's one of two things. It is either the altitude or it is one of your legs. All right, those are the only two things that we could put into those positions. The altitude is not given to you at all, so we're not worried about that. Over here, we're not given this leg. We're not worried about that. But what we were given is this leg right here. So that should be what we would have put into these two spots, x plus 2 here, x plus 2 there. All right. Then what the other numbers are, what this is the geometric mean is the adjacent side to this along the hypotenuse. So this is the adjacent leg. So that's going to be an x. And then here's the one that I just be careful of. Up here, when we wanted this full length, didn't we do 4 plus 32 to get 36? Here to get 14, we did 12 plus 2 to get a 12. So to get this full length, we need to add these guys together. That doesn't mean you can put 5x. Okay, adding those together is simply x plus a 5. If you put 5x, you're multiplying them together. Okay. So that is our setup. Now, you're still going to cross multiply. So we'll be a little more thorough here. I just write it as x times x plus 5 initially. And then we're going to cross multiply these guys. So I'm just going to do the x plus 2 and then show that we're going to do times another x plus 2. All right, both of these we need to distribute. On the left-hand side, the x is going to get distributed, so x times x is x squared. When we do the x multiplied by that 5, we would just get 5x. All right. The right-hand side, we have two numbers that need to get distributed. First, the x is going to get distributed, so you're going to do x times x, which is, again, an x squared. But then that x also has to get multiplied by 2 to give us a 2x. Again, a long time since we've done this, but if you remember now, this 2 also gets distributed. So now the 2 needs to get multiplied by x to give us another 2x. And then that 2 needs to get multiplied by the 2 to give us a positive 4. clean that up a little bit. The left-hand side, there are no like terms on the left-hand side, so I'm just going to rewrite it. But on the right-hand side, you'll see that we have some like terms, so we're going to go ahead and combine the two x's. So we end up with an x squared plus a 4x plus a 4. These are quadratic equations, all right? We revisit those a little bit in this chapter. The nice one about this, though, we want to get the x squareds on the same side. So let's say I subtract x squared from the right-hand side so that it would go away and we move it over. When I subtract x squared from the left-hand side, wouldn't these guys also cancel each other out? Yeah, so the nice thing is you now end up with actually a really easy equation to solve. Because now you just have this guy. So solve that, we'll subtract that 4x over. So we now just get the 1x that we want, and then we see that x is equivalent to a 4. Okay. Last one, gonna give you a few minutes. It's both rules, do number 7, and then we'll see how it's going here. So you have to do both rules. The two means can be this altitude or it can be a leg. You're going to find both of them. So see if we have those rules straight, and then we'll give you the homework if we're squared away with all of this. Okay. So if you're going to do the 6 over 30, that's actually this guy. The leg rule is if this is what we're looking for, it's the adjacent side compared to the entire side. If you're going to solve for y, then it's just these two guys not having to add one. There is two different. You're solving for y right now, so we also eventually solve for that x. This here is the correct setter to get your y. So once you cross multiply and solve that, you'll get y. But then we also need to figure out the x. Okay. Trip to the mountains. So all of that we're setting up.
Okay, that's what
Is this idea that the geometric mean we're looking for is one of two things. It is either this altitude or it is a leg. So when you come down here, if you're going to use the y is your altitude, so that's fine. But it's got to go in both of those spots. It's the same exact thing. So if you're going to measure y here, this also has to be y. And then when it intersects, that hypotenuse, see how it creates these two distinct points? That's what goes right here. So this now is what we can solve to figure out what we're going Pretty good, Maria. Pretty good. A lot of like regular kids, first period had a really hard time with that rule 180. But you just like hummed right through.
Wait, what was the 180?
Huh?
I just did 180. 30 times 6.
What is yours?
30 times 6.
Get out of here. You're lying to him.
I am?
Yeah.
Is 30 a perfect square?
She's trying to make you have the dark.
Huh?
What two numbers did you use to get 180?
Oh, 36 and 5. Okay, I was Oh, I thought she was.
Yeah, the 36 is the perfect square.
Okay.
Yeah.
I was thinking what?
That's good.
Just write down 6. It's 36 and 5, right? 36 is the
So whenever you do the mean is either your
yeah, 6
altitude
to square root of 5.
or the
Yeah,
so you did the hypotenuse one is your y. See, I guess these are right. So that means x is your leg. So that's got to be the mean. So that's yeah. And since this is the side that we're making for, it is the side that it is adjacent to. So immediately adjacent to, which is what? What's happening over here? The entire side is here. You'll add them. I mean, is 15 a perfect square? Is 12 a perfect square? So this doesn't mean it's good. It's correct. It's not correct.
Oh, is it?
Well, this one's not correct. This one's. Right. Tell your friend Sarah. She'll be off. It's 10 a perfect square. Great, isn't it? That's why Maria's so. Good back here now?
Use your paper to see if I got this one. Huh? I had to look at your paper to see if I got Y with it. Did you get it? Yeah.
All right, we're getting there. We're getting there. Okay, let's go over this so I can give you a little bit of time to do some of that homework. It's both rules. That's why I kind of did this one as the last one. Can we keep them straight? Do we know both of them? The order you did them didn't matter. You could do one or the other first. It didn't matter. So when we set these up, Maria, give me one of yours. Which one did you do first?
6 over Y equals Y over 24.
Good. So she did the altitude first. So she used the Y as the mean. And then that rule is when that altitude intersects that hypotenuse, those two segments that it creates is what we are looking for the value in between. All right. And then that's your setup. This one is the sneakier one, I think. Or no, because the 6 and the 24 gave us, what is 6 and 24? That's the 144. Yeah, so this is the nice one. So when we now crisscross here and get y times y to be a y squared, this one was nice. If you got this far, we should get what, Maria? Good, because that's our nice perfect square. Okay. The other one that's set up shouldn't be too bad, but you have to simplify it. It's a little trickier. So now when we go to set this up, when we do our little proportion here, again, the mean is one of two things. It's either this altitude, but we've already done that problem over here, or it is one of your legs. So this leg I'm not asking about, but this leg is what we are now looking for. So that's what we're going to assign to these two positions there. So that's going to be x and then x. And then what we're looking for that value in between is whatever the very next adjacent side along the hypotenuse is to that leg. So that is this guy right here of 6. And then Sarah, what's the other length then here? Good. The entire hypotenuse. So this entire length from here all the way to here, which is the sum of the 6 and the 24 together. Okay. Cross multiply. This is the one that was a little ugly. People were starting to work their way through this sum. We want to pick the largest perfect square possible. All right, Maria was the first one I saw had it. What'd you get, Maria?
36 and 5.
Good. 36 and 5 give us that 180. And then the square root of 36 is a nice perfect square of 6. So then this ends up being your answer. All right, 6 root 5. All right, so one of each.